For most of the last century, if you wanted to build software, you had to meticulously, painstakingly translate your ideas into a language that machines could understand, a language that was rigid and, frankly, unforgiving. Well, that whole era is coming to an end. Today, we're diving into a massive shift in how we create things, moving away from the tyranny of syntax into a wild new world that people are starting to call vibe coding.
And this quote from Andre Carpathy, man, it just nails it. The idea here is that you're no longer a translator, you're a conductor. Instead of typing out perfect lines of code, your main job is to communicate a feeling, an intention, a vibe, and you let an AI sort out all the messy details. So what does that really mean? It's a complete rethinking of how we talk to computers.
But this huge leap, it didn't just pop up out of nowhere. To really get where we're going, you have to appreciate where we've been. You can look at the entire history of programming as this one long 70-year climb to get further and further away from the raw metal of the machine. It's like we've been climbing this ladder of abstraction, reaching towards pure human thought. And this slide, wow, it really paints the picture. The first programmers were basically living in a digital dungeon, the nightmare of binary. I mean, this was a brutal, grueling world of manually flipping switches or typing endless ones and zeros, where a single mistake could bring the whole thing crashing down. The dream, the entire point of high-level languages, was to escape all that, to speak in logic, in math, in a language that could work anywhere and free up our minds to actually solve problems instead of just juggling memory addresses.
And here, you can really see that climb step by step. Back in '49, assembly gave us little codes instead of raw binary. A huge step up, but you were still chained to the hardware. Then Fortran came along and let scientists talk in equations. C in the '70s gave us this amazing mix of structure and power. Then in the '90s, Python made it all about developer happiness and just getting things done fast. Every single step took us further from the machine, and it all leads here, to 2025 and vibe coding. It's like the final rung on the ladder, where we don't even need a formal language anymore. All you need is an idea.
So what's really crucial to understand is how the job of the programmer has changed right along with the tech. We started as manual instructors who had to master a specific piece of hardware. Then we became architects of logic, then modelers of these big, complex systems, and now we're intent conductors. Our main role is to direct the AI, to communicate the big picture, and to achieve what is basically a total abstraction from the code itself. All right, so that's the history lesson. Cool, but what does this age of intent actually look like in the real world? How do you actually build something by just describing a vibe, instead of writing thousands of lines of code? Think of the whole process like you're just having a chat with the AI. It all starts with you describing a feeling, not a technical spec. You might say something like, make the login screen feel lively and organic, or I need a checkout process that feels super reassuring and trustworthy. The AI takes that, chews on it, and then spits out all the code you need across all the different files. And get this, when something breaks, you don't go hunting for a typo. You just tell the AI, hey, it's broken, here's the error message, fix it. And it does. It's this incredibly fast cycle of intent, generation, and feedback. And this right here creates a whole new breed of developer, the 100x engineer. For years, we've talked about the mythical 10x engineer, this coding genius who is just insanely fast. But today, the most valuable person in the room isn't the one who writes the most code. It's the one who can best direct and orchestrate whole teams of AI agents to build a product. Their skill isn't typing speed, it's high-level design and crystal-clear communication. It's a massive shift in what we even consider talent. Okay, but it's not all sunshine and rainbows. With all this incredible new power comes, well, a pretty big catch. The same insane speed that lets a 100x engineer build something in a weekend can also build a total house of cards. This is the dark side of vibe coding, what we're starting to call the vibe debt crisis. It's what happens when the code feels right and it works right now, but it's actually a ticking time bomb of security holes. And look, this isn't some, maybe someday kind of problem. We're talking about right now. This is a very real, very big number. Studies are showing that almost half, 45% of AI-generated code has at least one of the top 10 most critical security flaws. And why is that? It's because the AI learned from all the code we've ever put on the internet. The good, the bad, and the really, really insecure. And when you dig into the specifics, oh man, it gets even scarier. For some of the most common types of attacks, the failure rates are just astronomical. Look at cross-site scripting. That's a classic way for an attacker to inject bad code into a website. The AI fails to stop it 86% of the time. Log injection, where an attacker can steal sensitive data, an 88% failure rate. The AIs are just repeating the same mistakes we've been making for decades, but now they're doing it at a scale we've never seen before. And these are the sneaky little traps that are so easy to fall into, especially if you're not a security expert. Just to make things work fast, the AI will set up dangerously wide-open server settings. It might suggest using old, broken cryptography because it saw it in some ancient tutorial. It can even make up or hallucinate a software library that doesn't even exist, which an attacker could then create just to hack your app. So, at the end of the day, it's all about this trade-off, right? Vibe coding is unbelievably good for getting that first version, that prototype, that MVP out the door in hours instead of months. But that speed can create messy, undocumented code that's an absolute nightmare to maintain later. For the really important stuff, banking systems, healthcare software, that structured, deliberate, and secure approach of traditional development is still absolutely vital. So you're probably asking, well, what's left for us humans to do? It might seem like engineers are about to become obsolete, but the reality is actually the complete opposite. As AI starts handling all the simple, repetitive code, the value of real human expertise in things like architecture, security, and complex problem solving is going through the roof. And this quote just hits the nail on the head. It perfectly redefines the job. The senior engineer's role is shifting away from production and towards oversight. They're the ones who review the AI's logic to make sure it actually solves the business problem. They are the guardians of quality, making sure the final product is secure and scalable. They become the absolutely irreplaceable human in the loop. And you can already see the writing on the wall in the job market forecasts. In the short term, hiring for entry-level roles is slowing down because AI is taking over those tasks. By 2027, a huge chunk, 80% of the current engineering workforce is going to have to learn how to work with these tools, or they risk getting left behind. And by 2028, the biggest demand will be for deep specialists in fields like AI safety, jobs that require a lot more than just a vibe. This chart right here, this tells the whole story. Just look at this breakdown for 2027. A senior developer is predicted to spend only about 10% of their time actually writing code by hand. 60% of their time will be spent on high-level architecture and reviewing what the AI built. Another 30% on mentoring others. It's a total flip of the traditional role. The most valuable work is the thinking, not the typing. So if you remember just one thing from all of this, let it be this. This is not a story about machines taking our jobs. It's a story about a powerful new tool. The engineers who don't want to adapt to this new world, they won't be replaced by AI. They'll be replaced by other engineers who've learned how to use AI as a massive force multiplier for their own talent. And that brings us to one last really big question. For the first time ever, we are right on the verge of separating the idea of software from the tedious work of writing it. When the machine handles the how, we humans are finally completely free to focus on the what and the why. So, with 100% of our intent finally unshackled, what's the first thing we're going to ask for?